Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 24/5 Part 3 worksheet. Okay, first one. How long will it take for an investment of $5,000 to grow to $10,000 if it's invested at 6.5 per annum with interest compounded yearly? So, how long? Notice all of these on the worksheet start with how long. That's going to be time. We're going to solve all of these things for time. So, future value is what it's going to end up being, so that's 10,000. We start with 5,000, and then we do 1 plus our interest rate, which is 6.5, all over 100. Compounded yearly means that k equals 1, so 100 times 1, all to the 1 times t, because that's what we're trying to actually figure out here. Okay, so we got to solve for this t. Now, if you'll remember, whenever we get an exponent that's a variable, we always got to use logarithms. So what we want to do is we want to get this simplified down some so that we can use logarithms to figure out how long it's going to take. Okay, so first thing we want to do is we want to get rid of this 5,000. This is 5,000 times this, so you got to divide by 5,000. Okay, a lot of people want to try to subtract 5,000, but this is attached. This is being multiplied, so to undo multiplication, you got to divide, right? So 10,000 divided by 5,000 gives us 2. And actually, if you think about it, this number over here is going to tell you how many times more money you're going to end up with. So 5,000 times 2 gives us 10,000. So we're looking at how long is it going to take for our money to double. Okay, so we now can figure out what this is in here, right? So let's see, let's simplify that. 100 times 1, 2, that's just going to be 100, right? So we're going to put that into our calculator. We're going to do parentheses 1 plus 6.5 divided by 100. And that simply gives us 1.065. So this is 1.065 all to the t, right? Okay, so now that we have this here, what we want to do is we want to change this. Since we know we've got an exponent here that we're trying to solve for, we know we got to do log. So we'll do log of both sides. Log 2 equals log 1.065 to the t. And remember, once we do logarithm, this t can come out front here. So really it's going to be log 2 equals t log 1.065, right? And since we're trying to solve for t, this is t times log 1.065, so we're going to divide both sides by log 1.065. Log 1.065, and that's going to tell us how long it's going to take. Okay, so turn our calculator back on here, and we're going to do log of 2 equals, and then we're going to divide by log of 1.065, and that gives us that it should take about 11 years. 11.0 years is how long it should take. Okay? All right, for 3, how long is it going to take for an investment of $900 to grow to $1,200 if it's invested at 4.4 with interest compounded quarterly? So quarterly, that means that our k is going to equal 4. Okay, so we're starting. Sorry, we want to end up with 1,200, starting with 900, and then we're going to enter all the rest of our info in there. 1 plus our interest rate, which is 4.4 over 100 times k now is 4, so we're going to put a 4 here and a 4 times t here. Okay, first step is always to get rid of this original amount, so we're going to divide by 900 both sides, and 1,200 divided by 900 is the same as dividing 12 by 9, which gives us 1.333 repeating. So here's a big key on this thing here. You don't have to write a bunch in here, but you want to put as many digits in here as you can when you're doing the logarithm so that it gives you a more accurate answer. But for now, we'll just put 1.33 repeating, and then that's going to equal, and now let's simplify this. 1 plus 4.4 over 100 times 4. 100 times 4 is 400, right? Oops, can't read that. That's going to be 400, right? So we will do let's do parentheses. 1 plus 4.4 divided by 400. We don't really need the parentheses for that, but it's just good habit. Enter, and that gives us 1.011. So this equals 1.011 to the 4t. Okay, now we've got just one number on one side and another number to a power that has an exponent. Sorry, that has a variable in it. So this is where we want to take the log of both sides. Log 1.333 equals log 1.011 to the 4t. This 4t now comes out front. So we get log 1.333 equals 4t times log 1.011. Divide both sides by log 1.011. 011. This goes away. We're going to end up with 4t equals, and then we got to calculate this stuff out here. So here's what we're going to do. We're going to do log, and we want 1 point, and we want a bunch of 3s, so I'm just going to put a bunch of 3s in there. I know that's going to be pretty good and accurate, so I do 1.3 with a bunch of 3s on there. Hit the log, and then log of 1.333, enter. We get 0.124, and we're going to now divide that by log of 1.011. Oops, I missed the log part. Log 1.011, right? And that gives us 26.296. But that equals 4t, so our last step now would be divide both sides by 4 to figure out how long that would take. So we already have that 26.296. We simply just hit divide by 4, and that tells us it's going to take about 6.6 years. So we really should do little squiggle lines there that shows that it's about that long. Okay? Okay. Number 5, how long is it going to take for an investment of $50,000 to grow to $80,000 if it's invested at 5.1 interest compounded daily? Daily means that our K is 365. Okay, so if we're going to do this, we want it to grow to 80,000. Start at 50,000. 1 plus, our rate is 5.1 over 100 times daily is 365. Whatever goes down below here also goes up here, 365. And that's going to be for, we're trying to figure out how long that's going to be for. So for times t. Okay? First step, divide both sides by 50,000. 50,000. That goes away, so really that's just 8 divided by 5, because all the zeros are going to cancel out, and that gives us 1.6. So we get 1.6 here equals, and let's figure out what this 1 plus 5.1, 100 times 365 is 36500 is going to be this number here, right? So we're going to do 1 plus 5.1 divided by 36500, right? That's going to give us some really pretty small number, 1.001. You want to write out as many of these digits as you can remember. 1.00039, I already forgot. I already messed that up. It's 139, 00139,726, and that's going to be to the 365t. Okay, So now that we got a number here and a number here to raised to a power that's got a variable, that means we're going to want to take the log of both sides. So log 1.6 equals log 1.000139726 to the 365t. This 365t comes out front here. So really it's log 1.6 equals 365t times 1.000139726. And to get the 365t by itself, we want to divide by, oh, I forgot the log part. So that's 365 times log 1.000139726. I know it seems ridiculous to write that number out, but it will have an impact on your answer if you just go to a few digits. Okay, so divide both sides by log 1.0013976. Log 1.00, oops, forgot a zero here. 0.139726. Those go away, and we get 365t equals whatever this is. So we'll do log of 1.6 equals divide by log 1.000139726, and that gives us 3363.98. 3363.98 dot dot dot. Last step is to divide by 365, and we get that t is going to equal, so we just take this answer and simply divide by 365, and we get 9.2 years about. So squiggles, 9.2 years is roughly how long that's going to take to grow from 80,000 to 50,000. Okay? All right, last one here, number 7. How long is it going to take for an investment of $85 to grow to $500? Invested at 4.8 compounded monthly. So monthly means k equals 12. Okay, so let's write this one down. So we are going to grow to 500 starting at 85. 1 plus our interest rate, which is 4.8 over 100 times 12 to the 12t. Okay, first step, divide by 85, both sides. Okay, so we do 500 divided by 85, and that gives us 5.88235. 5.88235. That should be enough to get us a pretty accurate answer. This means we want to turn this 85 into almost 6 times the amount of what we started to get up to 500. That's what that number there means. Equals, and then let's do 1 plus 4.8 divided by 100 times 12 is 1200. Right? And we enter that, and we get 1.004 to the 12t. So now that we've got a number equals a number to some power that's got a variable as an exponent, we're going to do log of both sides. So we're going to do log 5.8825 equals log 1.004 to the 12t. Now that we've done log, that 12t comes out front, so it's 12t log 1.004 equals log 5.88235. We want to divide both sides by this log 1.004 to get rid of that. So that we'll just end up with 12t. So divide this by log, 1.004, and let's see what we get. So we're going to do log 5.88235. In fact, what we really should have done, what I should have done here is, oh no, I guess we had that already. Let's just do it the way that we were doing it here. That should be fine. Log 5.88235 equals, divide by log 1.004, gives us 443.87. And our last step, divide both sides by 12 to tell us how long that should take us. So we take that, divide by 12, and we get 36.98. So basically it's going to take 37 years, roughly. Okay, that's a long time to wait. But you're taking $85 and you're growing it to $500. That's but 37 years is a long time to wait. Okay. All right. That's all we have for the 24/5 part 3 worksheet problems. If you have any further questions, please feel free to ask. Thanks.